Our next speaker is Xiao Zhu from Tsinghua University.
So thanks for the introduction. And hello everyone, I'm Xiao Zhu from Tsinghua University. And I'm happy to present our work, HMEAE, Hierarchical Module Event Argument Extraction. This work is in collaboration with the guys from the WeChat and Xiangren from the USC. At first, let me introduce this task for you. Event argument extraction is to identify the entities in the sentence which serving as event arguments, and to classify their argument rules. For example, given the sentence contains the event is a transfer ownership event. Given the sentence and the event, Steve Jobs sold Pixar to Disney in 2006. An EAE model should figure out that Steve Jobs is a seller in this event, and Disney is a buyer, and 2006 is the time within. And the event argument extraction is the second stage of event extraction. The traditional event extraction pipeline is like this. First we have the unstructured text, and we input them to the event detection model, such as the first work mentioned. And with the event detection model, we have the trigger words and event types. And then we input those information into event argument extraction model, and we extract the event arguments to fill out the event structures and get the structured event knowledge. And we can see that the state-of-the-art results for event detection is about 75% in F1, and I think the first work improved it again. But with the event argument extraction, the performance will drop to about 60%, which is much lower. And so we claim that the event argument extraction is the bottleneck of event extraction now. So then I will introduce the basic motivation of this work. Existing models most treat argument rules as independent of each other, such as they classify the seller, the buyer, the time within independently, and without considering their dependency. In fact, with our human knowledge, we can see that some argument rules are conceptually closer than others, such as the relation between seller and buyer is much closer than the relation between seller and time within, right? So here comes the question, how can we formulate this kind of variable dependency? And in this work, we formulate it as a concept hierarchy. We commit that the seller and buyer is closer because they share the same superordinate concepts. By superordinate concept, we mean it's basically like a higher level type. It means that the seller must be a person or an organization, and so as the buyer. But the time within its superordinate concept is higher level concept is the time. So we think that with this concept hierarchy, we can model the concept dependency in the argument rules, and hopefully we will extract the event arguments better. So here is the next question: how can we utilize this kind of structured concept hierarchy to benefit our model? So then I will start to introduce our model. We use neural module networks, which is a flexible network architecture. Which means that the unified network consists of several neural modules. And the new modules are dynamically composed into the unified network. And with the flexible architecture by the neural module network, we can imitate the concept hierarchical structure, which with just the network architecture. And this architecture can provide effective inductive bias from human knowledge. It's the concept hierarchy for the event argument extraction models. And then I will introduce it. Here is the overall architecture of our model, and then I will introduce it in detail. And first, the most important superordinate concept module. We use one module for one superordinate concept, and one superordinate concept module is corresponding to one subordinate concept. And the module is essentially an attention module, which is to highlight the information, highlight the textual information related to the subordinate concepts. Take this as an example. The person module should highlight the information about the person in this sentence, and in this sentence it should highlight the embeddings about jobs. And for the organization, it should highlight information about the Pixar and Disney, right? So with with the superordinate concept modules give the attention scores for the hidden embeddings. And then we use the unit module to compose the attention score, to combine the attention scores produced by the superordinate modules into a unified attention score, and apply the attention on the hidden embeddings of the text, and then get the row-oriented embedding, which only has the subordinate concepts for the specific argument row, which means for the server, we only highlight the information about the person and organization in the row-oriented embedding. And the operation of object unit is simple. It's just to calculate the average of the attention scores. But the point here is that we should compose different subordinate concept modules for different specific argument rows. That is how we use the module network to imitate the hierarchical structure. So the object unit module depends on the argument row. And then that the argument row classifier is somehow a simple module. It's just to predict whether this instance is of this argument row. The server classifier to classify the server, and given the embeddings, both the row-oriented embeddings and the overall instance embeddings. So final part, the final part is the instance encoder, which is trivial, because it is to encode the text and the candidate entity position information into the embeddings, hidden embeddings, and we use a feature. And as we stated above, the row-oriented embedding produced by the hierarchical module attention only hides the information about the subordinate concepts. But to make a decision, we should also see the global context informations. So we still need an instance embedding to encode the global text information. And so we use a feature aggregator, which is essentially a polling, to aggregate all the hidden embeddings into a unified instance embedding and feed it to the attention row classifier. And with these two embeddings, the attention classifier, the argument classifier will classify the argument row. And our HMEAE is essentially agnostic to the encoder, and in the experiments we use the CNN, convolutional neural network, not the fake news, and the BERT. So in fact, we can use more kinds of encoders, but it's not the most important part of this work. So then let's start with the experimental results. And first, we also evaluate our model on the most widely used data set in the event context. It's the S2005. And we can see that the overall results of our model, our HMEAE-CNN compared with the DMCNN, and our HMEAE-BERT compared with the DM-BERT, they both achieved about 2 points improvement, which is, I think, a significant improvement. And our HMEAE-BERT achieves state-of-the-art results on the S2005 English data set. And one thing to see is that we use the trigger. This is the second stage of event extraction. But this work do not involve the first stage, the event detection. So we use the trigger information and the event type information, which is the same event type and the trigger words extracted by the event detection model, which is also our baseline model, DMCNN and DM-BERT. So the comparison between HMEAE-CNN and DMCNN and the comparison between HMEAE-BERT and DM-BERT is fair, because they rely on the same first stage results. And then we think one data set is somehow weak, so we also evaluate our model on the TAC KBP 2016, and we compare it with the context systems, and also we reproduce the DMCN and DM-BERT as baselines. The conclusion is the same. And here comes another question. Do the subordinate concept modules really capture its corresponding concepts? Really capture the information about its corresponding concepts as we exposited? It's hard to say that because we do not use any direct supervision to the subordinate concept modules. We expect that it will understand the the concept from the commonness of the data, where the data is annotated with its subordinate concepts, the argument rule. And do they really do it? So we use a case study to verify it. And we can see this figure. The left is the sentence, and the sentence is sampled from the S2005 English dataset. And the below is 3 different subordinate concept modules. We can see that the person really gave higher score to the embedding on the embeddings about the barrier with the person name, and the organization really gave higher score on the VND. So mid position is a little bit wrong. And the time argument, the time subordinate concept module really gives higher score on the Wednesday, which is also the time. So we can see that it works as we expected. So to conclude, we propose a modular architecture imitating a prior structure. In this work, it is the concept hierarchy, and it can provide effective inductive bias for the task. And in the future, we'll explore to extend it to other tasks or other kind of priors, not only the concept hierarchy. And a more interesting problem is that can we automatically design the architecture? The concept hierarchy here is designed by Holman. And these are our future works. We have released our code and paper. Thanks for listening, and I will take questions.
Thank you. Questions? I have one. So when you do the prediction, you do it, is it a sequence tagging prediction? You're doing word by word? You have the boundaries for the arguments, and how do you actually?
No, in fact, our encoder not only encodes the text, but also the position information of the candidate entity. We predict the argument rule for one entity. In one instance means one sentence and one entity, and we should predict the argument rules for this entity.
And the numbers you're getting are with gold standard entities, or is it with system entities?
Sorry?
The performance you're getting, the 56? The 59, sorry.
Yes.
Is this given true entities and event types, the trigger?
Yes.
Or is it with the system output?
The entities is annotated by the S2005 dataset.
And it's the gold standard one you're using?
Yes,
as
the golden entities.
Hi, thanks for the talk. And the modular idea is very impressive. So I'm not very familiar with this area, so I wonder how you design the concepts for the modular. Do you have some existing ontology about these concepts, or you just manually design some concepts?
Yes, a good question. We just manually design for the event argument rules. And I think for the event types, the event detection model is with a taxonomy in the S2005 dataset. But for the event argument, there is not an existing taxonomy. And we also released the taxonomy constructed by our home experts in our papers, and you can refer to my papers for the details.
Okay, thank you.
Thank the speaker again.